Okay, so we've got all our data loaded, we've got it cleaned, we've got it spliced, and now it's time to look at age. So what do we need? Well, we just need the regular data and an age model. So we have an age model here in the folder age depth fit, and this is a fit to some age and depth data that you will learn how to produce in another video. But for now, it's a depth model. And it looks like this. If we plot it from 0 to 440 meters or so, and from 0 to about 18 million years. Okay, so there's two ways that we can put plot data versus age. One is to plot it to create an age wave and then plot the data versus age, and the other is to plot it versus depth and then append a kind of a fake age axis opposite depth axis. So first one, under COD data, go to depth to age and select data depth to age. So select the folder containing the age model, that's age depth fit, select the age profile, and that's the age wave. Select depth profile, and that's the depth wave. We'll continue with that. Select the folder with the depth data. That's GRA in this case. And if we look for the depth wave to convert, we're going to use S, that is the spliced data. And we're converting CCSF to age. Enter a name for the new age wave. See, we're maintaining our three-part naming convention, S, GRA, and then underscore age. The reason that you have to type in the name is sometimes you have competing age models, and it's useful to be able to say age 1, age 2, or age Roy, age Anna, to distinguish them. But make sure you have age in the third part of the name. So let's continue. And bingo. Okay, don't need that. Now, if we go to GRA, where are you? GRA, and slide down to the bottom, what we'll find is 1338S underscore GRA age. Okay, let's take a look at what it looks like then. Data, plotting, new data plot. 1338S, GRJ, 0, right. Now, we've created an age wave, so we want to call this age. And if, as I said before, if we had age 1, age 2, age 3, that's where you would put this, age 1, age 2, age 3. And the name of the x-axis now is age. And that's also why we want age in the name of the data. So we continue. And there we go. Here's our data versus age from 0 to 18 million years. And so if you want, just for the heck of it, we can horizontally expand this guy. We could put a cursor here and a cursor here, and then we would go down here and look at delta x, and we'd find that that's 100,000 years. What do you know? Let's try this one and say that one. And delta x is, well, 111,000 years. So we're looking at 100,000 year cycles along here. Okay. Now another way to do this is to plot the data versus depth, but then add age. So let's go back to plotting. And we want a new data plot. S, GRA, blah, blah, blah. Now we're back to CCSF because we're plotting versus depth, and we go depth here and continue. Okay, here's our data versus depth. Now go back up to COD data, depth to age, and we want to calculate age ticks. Okay, so it's through 1338. Age increments, we got a broad scale here, so let's make it 1,000,000 years. And the folder containing the age model, that's our age depth fit. So let's continue. Again, they're asking for the age wave and the depth wave. And that's done. Now, if we go down here to the very bottom of the data browser in our extras folder, what you'll see here is age ticks. And we've created two new waves. Let's just take a quick look at them. And one of them is actually just strings of the ages that we selected to go onto the ticks opposite the depth. And these are the interpolated depths to these ages in millions of years, of course. So, last thing to do, go up to COD data, depth to age, and we want to add age to depth plot. Text wave with tick labels, that's the age ticks. And wave with tick depths, and that's the tick depths. And there we go. So now we have this scale and this scale. So this scale is pinned to that one. If I were to want to try to change something, say the range of this one, and I double clicked, what you would see down here is that you would actually get the range of the lower axis. And that's because these are just, as I say, pinned to those. So if you wanted to just look at, say, 7 to 8 million years, you would do this, and horizontal expand. Now, that doesn't really tell you much. So let's go back up to data, depth to age, and we're going to recalculate the age ticks. So instead of 1 million years, and this is 200,000, so let's look at 25,000. That's all the same. Whoops, well, that's probably too much. But let's take advantage of it. Okay, so this is every 25,000 years. Now, we can't do delta x for the age axis like we did with the plot versus age, but we do have one way to get a little bit better idea of what's going on. And that is if we put a cursor there and then go up to COD functions, to cursor styles, we can go vertical. Now you can move this guy at any point you want, and you're going to get a pretty good idea of what the age is. And if later on you want to get rid of that age axis, let's go down here to remove age ticks. Now those ticks are going to remain down here in the extras, and you can put them on any depth plot you want at any time and recalculate them at any time. Just beware one thing though. If you have age ticks on, say, 3 different plots, and one of them is 0 to 400, one of them is 0 to 18 million, and the other is, say, 0 to 1 million, they'll have very different ticks, but there's only one set of ticks. So changing ticks on one graph is going to change ticks on all the others. If you have a special case and you want to save, say, these ticks, just rename them and then save the graph. And the graph will be saved with the renamed ticks. Then you can go on to calculate new sets of U38 underscore age tick depths. Okay, that's it.